All right, so we were going to pick up on 62 from the book. So we've got negative 3/5 sine. Wow, let me start over. We have negative 3.5 sine of 2x minus pi over 2 minus 1. So what is the first thing that I need to do?
Find the amplitude.
Amplitude, which is
3.5.
okay.
And now we do whatever Riley was trying to say.
Get rid of the 2.
Yes, we have to take the 2 out and move it out in front of the parentheses. So Virginia, what I don't think I told you this I think I told them yesterday. But when we have a number inside the parentheses, we have to take it out, and it has to be out front to be B. So the way our formula is written in the notes is a little bit misleading for what it's supposed to be. So we need to remove a 2 from this entire piece here. So I'm going to rewrite this as negative 3.5 sine of 2 times x. If I remove a 2 from here, what do I get?
Pi over 4.
Pi over 4 minus 1. So now what can I do?
Find the period.
Which is
Pi.
okay, so 2 pi over 2, which is pi. Now what?
I don't know what it's called with the F thing.
Frequency.
We don't need frequency to actually graph. That was just a couple of the problems yesterday was asking us to find frequency.
Like the period over 4. I forgot what that's called.
Yeah, the scaling of it.
Yeah, that.
So this was step 1, step 2, step 3. So pi over 4 is going to be our scaling. Then what?
Right or left?
So which way is this one going and how much?
Right. Pi over 4.
Right, pi over 4. And remember, we're using the modified formula here. Next, down 1. And what's the last thing?
It is reflected.
It is reflected. So when I initially graph the parent function, I'm going to go ahead and do the reflection because all it's doing is it's taking it and it's flipping it over. So I've got an amplitude of 3.5, and I know it's going to be shifting down 1, so I'm going to make sure I might make this graph kind of big. I'm going to do increments of 0.5 for me personally.
So can amplitude not be negative? Or
Correct.
okay.
It's the absolute value of it.
Okay.
One of the wonders of absolute value. Can never be negative.
Now, I'm making this graph obnoxiously large just so that we can see everything that's happening, but it doesn't have to be this big. All right, so I've got the amplitude on here. Oh, we need increments of pi over 4. So I'm not actually going to write all of them. I'm going to do every other again so that we can see it a little better. And I think it's going right pi over 4, so I'm going to do an extra. So this is going to be pi over 4, and I'm just going to write pi here. As long as you know what the little increments are, you don't necessarily need to label every single one of them. The teachers that I had were always like, you need to label every single one of them. And I was like, that just seems so excessive. Like, I know what they are. Like, they wanted to see that we knew what the increments were.
Oh.
But they didn't teach scaling like this. So if you show the scale, then you know what it is, you know. All right, so sine starts where?
Origin.
Origin and typically goes where?
It'll go up when going to the right.
Goes up. Yep.
But since it's reflected,
It's going to go down. Okay, so we're doing the reflected with the parent function all at the same time. So I'm going to do this. I'm going to put a little... I'm just going to do that there, so that way we can see what's happening. And then when I do the right and the down, I'll show the other colors that I'm using for that. So I'm going to go down, and it's at... The amplitude was 3.5, so that's going to be down here. Here. This point, it's all the way up here. This one is here. So that's one full cycle. And so, like, if it told us that our domain was from 0 to 2 pi, we would need to do another cycle of this, basically. But it just said out to pi. Or we're just going out one cycle. All right. So now I'm going to do right pi over 4. So I'm going to do that in red. So every point, I'm shifting it to the right one set of pi over 4.
It's only 5 points, right?
Yeah. 1, 2, 3, 4, 5. Yeah. I'm gonna use light purple. All right, so then down 1. So every point is coming down 1. And it's the red points are going down 1. So this is the final one.
So what were you saying about, like, if it was 2 pi, we'd have to do...
So, like, if the domain, so some of them, like, these ones don't, but, like, let's say that they told you that they wanted you to graph it on the domain 0 to 2 pi, then we would need to go all the way out to 2 pi. Like, we technically only went to pi, because that was one full cycle. And as long as you can graph one full cycle, like, the process just keeps going, so you would be fine. But if they said you needed to go out to 2 pi, we would have to take it and go all the way out again.
Okay.
Basically, we would have done 2 cycles in that
So
interval.
it's pretty much like a bigger graph.
Yeah. So some of the problems in the book, which, like, we didn't do those because I was like, I'm not worried about you graphing, like, these, like, basic ones. If you can do this, like, you're fine. Do you know what I mean? Like, if you can graph, you know, out one cycle, you can graph 8 cycles kind of thing. So we didn't even do a lot of those that, like, don't have the shifts. We basically just graphed the shifts ones yesterday. All right, do y'all feel like you need to see another one, or do we think we're okay?
I think I'm good with those.
Okay. So what I'm going to do is I'm going to give you a few that you're just finding, like, the amplitude and the period, and if it's reflected, obviously say that, even though the instructions don't say that, and then a couple of the frequency ones. So 1, 9, 15, which is one that needs frequency, so just maybe make a note of that. And then in terms of the ones that you're actually graphing, 61, 63, and 65. Now, 65, I'm going to tell you, there's something in front of x, but you're going to notice x is not in parentheses, okay? So in 65, it says 2 pi x. You're not, like, taking out a 2 pi because it wasn't inside of parentheses. The only time we're pulling it out is when it's inside, like it was up here. And then if there's no parentheses here, so let's say it was, like, the cosine, 3 cosine of pi x plus 1, what's happening to that graph?
It's going
Up 1. Okay, if there's not parentheses, it's going up or down. So the only time we're worried about left or right is if there's parentheses.